Yeah, good afternoon. Um, I'm going to proceed to the next topic under inferential statistics, uh, which is ANOVA, analysis of variance. In the previous class, we did the tests, and I told you the principles, the first principle and the second principle in which you can interpret the t-test value. But this time around, we are going to be looking at ANOVA, which simply means analysis of variance. ANOVA is used to compare mean of more than two groups. I mean, three, four, or more groups. That is what we use ANOVA to do. And the two major things that is really, really important is knowing the p-value, which is similar to what we do in t-test, which is also known as sig value, and also the f value, and also the f value. F value simply means variance between groups divided by variance within groups. So let's quickly look at the major data that we are going to be using for our for our work. So now we are going to quickly look at the what is it called? We're going to quickly look at the data that I'm going to use to explain the ANOVA. I purposely decided to use the data that is a little bit similar to t-test so that you understand the difference between the t-test and the ANOVA. Don't forget that I used the same data when I was taking you t-tests, but the only thing is that I used two group, which is what? Control and what? And drug. Sorry, control and drug A. But this time around, because we now have two different drugs that is being manufactured that we want to test, so I needed to add 3 equals drug B. And I'm going to use this example for the analysis of variance. If you want to look at the previous video, just search on our YouTube channel. You see the video that I did on t-test for testing if a drug is effective or is good or not for curing a particular disease. So now in this case, you can see that the first variable is the group, but in this case, we call it the factor. That's when you are using ANOVA. You don't call it group, we call it factor, while this one will go to the dependent list. So let's go to the business so that we'll see how we can easily use this. Let me close all this. Okay, so I just decided to close unnecessary stuff that I have. Close. No, no. Okay, that's good. So let me reopen my SPSS so that I'll be able to import this particular data. And don't forget what I told you. I said the two major values that are important, p-value, and the second one is the f value. The f value, the p-value, and the f value. So now, sorry, my this thing is still loading. Just trying to take my time so that okay, I think it's opening already. So now, so let's try and import the data. I'm going to click on open data Then I will go to Excel, then anova. I think it's under download. Let me see. I produce it. I'll click on open. Okay, this is it. Okay. Now the first group is the control and it's one. The second one is the drug A and the 333 is the drug B. So then I'll go to analyze, then I'll go to compare mean, I'll go to one way another. Now getting here, don't forget what I told you. This blood group, because it depends on the value you get from the blood group depends on this drug, so it's dependent list. So I'll take the dependent list. Why this one? Go to the factor. That is the factor that determines the dependent list. So after that, I can do the other settings once and for all. Going to option, let me pick descriptive. Going to post awk, pick Turkey. If the data points are the same, what I mean by data points are the same is like the 1111 control, they are 1, 2, 3, 4, 5, 6. The 2 is 1, 2, 3, 4, 5, 6. You understand? They are the same n. You understand? So if they are same n, you pick Turkey. If they are not the same n, you you pick game OL. You understand? But let's pick Turkey and leave the significant level in 0.05. Click on continue. At the end of it, click on OK. Okay, now this is the one way ANOVA. So I'm going to quickly interpret the data. The first one is descriptive. I was able to get the average mean of each of them for the control, for the drug 2, and for the what? The drug 3. These are the average mean. Can you see that the drug 1, which is the control, the blood pressure still remain the same. For the drug 2, the blood pressure really reduce. You understand? And drug 3, the blood pressure is a little bit higher than this one. But with all this, we must get the p-value or the sig. The essence of the sig is to know if there is a significant difference. Because if there is a significant difference, that is when the hypothesis can be alternate. You understand? That is when you can go on with the analysis because it's reasonable. So in this case, the first principle, according to what I told you, for p-value, if the value is what? If the value is less than what? 0.05. So it means that it's what? Significant. Hmm? Or there's a significant difference. So let's see. So in this case, it's less than 0.0, it's far less than. So there's a what? A significant difference. Exactly. Now, after that, the next thing is that let's look at the F value. Let's look at the F value. I don't forget that I told you that the F value is variance between group and what? Divided by variance within group. Now, I quickly need to really let you understand this. When I say variance between group, that is for each of the groups, which is control drug, the drug A and drug B, the variance between them, that is, are you getting me? That is one. That is, I don't know how to explain more than this. Let me try and look at the exact data. Maybe I will use it to do better here. Yeah, look at me. This is group one. This is group what? Two. and this is group 3. So the variance between group is when you are actually looking at different what groups and you are comparing them to each other. As variance between groups. Are you getting me? So when you are trying to look at the mean, the average mean of each of the group compared to the what? To the to the to the total average mean. So, but if I want to say it in a layman language, it means that how different are they to each other. But when I say within group means that okay, I'm talking about one on one. So what are the variance within this group? Still within one. What is the variance within this group? But when I say variance between groups, that is the variance of this compared to the what? To the variance of this compared to the I think I've been able to explain better now. So variance between group divided by variance within group. Ah. So now after this is clear, so by the time it is divided, the value is 144. And it said that when you have a high F value, it means that there is a what? There is a significant difference. Do you understand? There's a significant difference. So in this case, we have an alternative hypothesis, and there's a significant difference. But we can continue further in this by carrying out our post hoc test. The essence of the post hoc test is now to relate each of the group to each other to really see if there is a significant difference. If there's a significant difference. As you can see here, multiple comparison is comparing 1 with 2 and 3. Is comparing 2 with 1. No, let me start from this one. It's comparing 1 with 2. This one also 1 with 3. Like now, between 1 and 2, you could even see that in this place, it's telling you that there's a significant difference 0.00, 0.00, 0.00, 0.00. But now let's come to this part. Let's come to this part. Okay, this is I'm coming. This is look for 2. This is okay for 2 is giving us the blood pressure. For 1 is giving us the blood pressure which is still high. For 3 is giving us what? The blood pressure which is a little bit what? Low. But with this sig value is a sign that with each of them, like comparing the control with drug A, there's a significant difference. Comparing drug 1 to drug 3, there's a what? Significant difference. So try it on your own and give me a feedback on on it. Thank you.